Hello, welcome you all on my video lecture series. In Model 2, Lecture 1, we are going to talk about random variable. So those who have gone through the probability and the topics related to probability up to Bayes theorem, they can go to the study of random variable. Basically, random variable is that we can say it is a bridge between probability and statistics, where the probability ends, the use of probability starts, and it is termed in the form of random variable. So in this short video lecture, we will talk about the random variable and its property. Few examples we will see, and in detail, definitely we will go to the next lecture. So first, what is a random variable? Suppose we have a probability space that is S psilon p. So what is random variable that we treat as a x here that you can see the x is the random variable. X is the random variable. It is what? It is actually a mapping between S to R, where this S is the sample space set of the all possible outcome, and R is the set of real number that is defined minus infinity to plus infinity. So basically what we do in the random variable, we assign each and every outcome, that is the element of sample space, to the particular number. It is real number. So such that for every A belongs to R, X belongs to S, Fx is less than or equals to A. It is for all epsilon, belongs to epsilon. So X is the element of sample space. Usually it is some outcome is there, and once we talk about the probability of this, that is in the form of less than or equals to A, that we can define. For example, if you are tossing a coin 2 times, so what will be the sample space? I draw in the mapping form like that. So sample space will be what? Either both head will become first head, second tail, first tail, second head, and tail will be there. And there is a set of real number that we define here, and you have a mapping this one. So what we define, suppose we talk x. What is x? X is what? Head comes. Head comes means what? We are talking about number of times head comes. So what we can define here, if we are talking about the suppose I write here 0, 1, 2, 3 like that. So you can count here the number of head how many times comes. So number of head comes here 2 times. So it is mapped to 2. In this 2 condition, it is mapped to 1, and the tail that is mapped to 0. So in this way we define the what function. So how we can write x? X is what? X is equals to 0, 1 and 2 only. So the range is what? 0, 1, 2 that we define. X is not equals to 0, 1, 2. X such that fx is equals to 0, 1, 2 that we can write. So ultimately random variable is what? We arrange all the outcome of the sample space in the form of number system. Suppose you say the tail comes, that is okay. Also that we can define. So the x is the number of times head comes. You can define y, that is the number of times uh, tail comes. So in this way you can define the random variable. Suppose you are tossing a coin 3 times. So random variable will have the range that is from 0, 1 to 3. The question is, can it be negative? Yes, sometimes it can be negative. So x is called one-dimensional random variable. Here we have defined random variable for one-dimensional. If it is in the pair form, then it is will be two-dimensional, or maybe extension three-dimensional that we can define. So bivariate is there. X and y, two random variables for the outcome that we can define for the bivariate. In that case, x will be what? It is a mapping from S to R square. s to r square that define the two-dimensional case, then x is having value which has two components. So let's say x and y, right? So in this way we can define. So in such a way you can define up to n dimensional random variable. Again, the sample space that is mapped to the Rm. Now if we talk about here, uh, okay, so what we can understand here, the set of values which random variable x takes is called the spectrum of x. That is defined in the form of what? A spectrum of x. For example, a random variable x having the countably infinite value, that is possible. We cannot correlate always for tossing of a coin. It may be anything, right? So a coin is tossed until a head appears. Its sample space, that will be what? Until its head appears. It is infinite series. So again, it may be possible the first head comes. If the second head, then first will be tail, and sequence will be in such a way. So t tends to infinity may happen. Let x denote the number of times the coin is tossed. Then x is a random variable that I have defined earlier. If you are defining 2 times or 0, here we can, okay, number of times tossed here, so it is 1 2 3 that we can define. If you are talking about head comes tail comes, then 0 we have to add in this x. So what happens, x can be defined in the form of what? Number system. So number of head comes, that we can define 0 1 2 like that. Also that is the value of random variable that we are defining. It comes from the range. So x is infinite, a countably discrete random variable it may be, and it may be the continuous also. So two type of random variable that we can define, that is a discrete and this is the continuous. Continuous means what? If the fraction is coming here, which is also real number, decimal places, that we can define for the continuous random variable. If you're counting, that is discrete. So tossing of a coin, that is the example of discrete random variable. In coming slide, we will talk about the continuous also. Okay. For example, a point is chosen in a circle C of the radius r. Let x denote the distance of the point from the center. So what we can see here, there is a center here and you are having a distance from a particular point. So in that case, these values between 0 to, suppose r is the radius, so 0 to r it will be. So any number that you can predict between 0 to r, suppose that r is equals to 2. So what happens, that distance will be either 0 and r. So any real number that you can define for this one. So it is a very good example of continuous random variable. So x lies between 0 to r. So x says that x lies between 0 to r, that we can define. So here what we can define, x is the uncountable set. X is what? Uncountable set. So it is a continuous random variable. So any measurement, if we are talking about the distance, length, uh, height, weight, that also you can consider as a continuous random variable. But suppose if you are talking about the height of a students of the particular batch or classroom, so it is what? It is a discrete type that you are counting here. So in such a way, random variable we can define also for such measurement. Now, so what we can analyze here, so a point is chosen in a circle C of radius r. Let x denote the distance of the point from the center. Same thing that we have described here. Okay. Some statement that in mathematics we say the theorem, but you can consider as a remark, as a statement, whatever you can remember. For in mathematics, you can remember these statements, but the statement is very important to analyze any topic. So x is the random variable which is as mapping from s to r. R is from minus infinity to plus infinity. Then x is a random variable if and only if x belongs to x and x value of x is less than or equals to a, which belongs to epsilon, where a is any real number. So it is very true, any real number that we can define, and the probability also in such a way we can define. Okay, now second statement is what? If you have two random variable, let's say x1 and x2, be two random variable and c be any constant. It may be the real, it may be the complex. In that case, c of x1, x1 plus x2, x1 into x2 are also random variables. So that we can define here. So in the place of c, here also you can write c1, c2. That is also possible. That is also random variable. Okay, that I have written in the separate theorem. So according to book it may differ. So third statement is what? If we are talking about the two constant terms c1 and c2, and x1 x2 are the random variables, then c1 x1 plus c2 x2 is also the random variable. So by virtue of this statement, we can these two also we can have the third statement. So either you can club with 2 and 3. So next is if xn is a collection of random variable defined on set S. So xn, that is the number of random variable that you can define. For example, we are talking about the tossing of a coin. So one random variable that you can define, the head comes. Other random variable that you can define, the tail comes. So in such condition, the supremum of xn, because we can define number of random variable, so supremum of xn, infimum of xn, and the limit n tends to infinity, supremum of xn and infimum of xn are also the random variable. That is also random variable. Few examples I will give later regarding these statements. If x is the random variable, then 1 upon x, where 1 upon x is equals to infinity. If x of x is 0, is also the random variable. X plus, that we define maximum of 0 of x, that is also minimum of max of 0x, also that can be defined. Mod of x are the random variable, maxima, minima, everything that we can define as a random variable. So mod of x are also the random variable. Mod of x, how we can define? If you're talking about the distance only. So distance is only the positive things, whether it is from left or right. So that you can define as a mod, distance, positive value that you can take. Next is the statement that is x1, x2 be two random variables. Then maximum of x1, x2 and minimum form of x1, x2 are also the random variable. If x is the random variable and f is the continuous function, then fx is also a random variable. So this is very good example. If x is the random variable, then you can define fx is equals to x square plus 2x plus 3, like it is a polynomial which is continuous, so it is also the random variable. If x is the random variable and f is an increasing function, then also fx is also a random variable. This is also increasing function that you can define. And f is bounded, then also it is random variable. So all three statements 7, 8, 9 that you can club, x is the random variable and f is a continuous, increasing and bounded, then it is said to be what? It is a random variable. So in the short small lecture series, I have defined only the random variable, that is the discrete and continuous. Some properties are also discussed here. So in the next lecture, we will talk about the discrete and continuous, and few examples definitely very soon. I will upload this video lecture. So thank you for all of you for watching this video. You can like, you can subscribe this my channel to get new updated video lecture. These days we are talking about probability and statistics model 2. So do not forget to subscribe, like and share with your friends. If you have any query, definitely write on the comment box. Thank you. Thank you for watching this video.